This video is Sampling and Data Part 3, Variables and Measures of Data. So first let's talk about levels of measurement. So the way a set of data is measured is called its level of measurement. And data can be classified into 4 levels of measurement. They are from lowest to highest. There's the nominal scale level, the ordinal scale level, interval scale level, and ratio scale level. So we're going to talk about what each of those are. So the nominal level, this is data that is qualitative, categorical. We talked about qualitative data earlier in the first or second video. I can't remember. I think it was the first video. But it has no natural order. So what do we mean by order? So examples include breeds of dog, colors of shirts, flavors of soda, models of cars, states of residence. You cannot put these in order. And before you ask, alphabetical order doesn't count here, okay? Because you can put anything in alphabetical order if it's categorical, qualitative. So outside of that, can you put breeds of dog in order? And you really can't. Now, could you put breeds in dog in order according to size? Yes, you can, but then you're using the size to make the order, and then that makes it quantitative instead. So the breeds of dog by itself cannot be ordered. Colors of shirts can't be ordered, and no rainbow order does not count. Flavors of soda cannot be ordered. Not unless you put some kind of quantitative data with it, but the category by itself cannot be ordered. So that's nominal. Then there's ordinal. That's also qualitative data. Remember, qualitative is no numbers, but it does have a natural ordering. So you might wonder, how could I order categories? So think about this: sizes of popcorn, small, medium, large. Officers in a club, president, vice president, top 5 national parks. Now the national parks themselves, that would be qualitative. However, once we add these ranks, that makes it quantitative, or not quantitative, but the numbers themselves will allow you to do the ordering. So because if they said the national parks in the United States by itself, we would say that is nominal. But once they say the top 5, and that would be ordinal. So level of agreement for a new law: strongly disagree, disagree, no opinion, agree, strongly agree. You can put that in order, levels of agreement. Okay, so nominal and ordinal describe qualitative data. The next two are going to describe quantitative data. So quantitative data, we can use an interval scale or a ratio scale. So the interval scale is quantitative, and there's no starting point. So that means it has values of equal intervals that mean something, such as a thermometer having intervals of 10 degrees. Examples: Celsius temperature scale, Fahrenheit temperature scale. There's no starting point for those, because you can have really high temperatures, and then you can have really low temperatures below 0. So you can have numbers in the negatives. So there's no real starting point there. So that's the best way I can tell you to figure out if it's interval or not is ask yourself, is there a starting point? And usually the starting point is 0. Ratio scale, time on a clock with hands, that would also be interval scale, because it just keeps going around and round and round and round and round. There's no starting point. So the ratio scale level, that is similar to interval, but it does have a starting point. So examples that have starting points are scores on a stat exam, ruler measurement, income earned in a week, years of education, number of children. All of those start at 0. They all have a starting point. I was going to make 4 videos, but I think this one is so short. The part 3 was so short, I'm going to go ahead and do part 4 as well: statistical study and design. So let's talk about some experimental study terms. So more vocabulary. So we have experimental units. This is the individuals being studied. Now, it could be people, it could be animals, it can be objects. Okay, it could be something like floor tiles or posters, towels. It doesn't have to be people. Then the response. That's what we measure about the individuals. So when we're collecting the data, we might be collecting their blood pressure on a new medication. The explanatory variable, that's the variable that causes a change in the response. So the goal is to identify an explanatory variable and see how much of a change is caused. Example, the dosage of a new medication could be what is causing a change. More terms. Treatment, this is a big one. Treatment is a type of explanatory variable, but specifically it's one that is introduced to the experimental units. It's introduced by the investigator, the person doing the study. So something new introduced. Then there's a lurking variable. That's an additional variable that can obscure the results of the study. Men tend to have higher blood pressure than women, so think confounding. Control group is a treatment group to which nothing is done except a placebo. A placebo is a fake treatment. Then we have blinding, and that's ensuring that those involved in the study don't know what treatment group they belong to, hence the use of placebos. Double blind is when the researchers don't know. That's really the best way to do it. If you've ever seen Grey's Anatomy, there is a season when two of the doctors, Meredith and Derek, are doing a study on a new drug for Alzheimer's disease, and they're doing a double-blind experiment because they have the control group who gets the placebo, and then the group that gets the treatment, the new Alzheimer's drug. And they're doing it as a double-blind experiment because they don't know who is getting which treatments. They let a computer decide that. The computer generate who's going to get which treatment, and they don't know until they are doing the treatment. That's when they open the envelope and find out which one's getting the treatment. So that's an example of double blind. Then there are two types of studies. There's observational and randomized experiment. So the difference is observational is a study where no new treatment is given by the investigator. Everything is through observation. Now, here's the thing that I don't want you to get confused. You have to observe people or do some sort of observation a lot of times, even with the experimental study. But the difference is that no new treatment is given by the investigator. Randomized experiment is a study where a new treatment is given to the sample by the investigator. All right, so let's look at an example. Let me find it on here. Oh, that one already has the answers, so never mind. Okay. I'll come back here and do it. Okay, so to assess the effectiveness of a new method for teaching arithmetic to first graders, a simple random sample of 50 first graders were taught with a new method, and another simple random sample of 50 first graders were taught with the currently used method. At the end of 8 weeks, the children were given a test to assess their knowledge. So what we're going to do is we're going to pick out different pieces that represent the different new vocabulary words that we just learned. So the population. That's who we're interested in studying. We're interested in studying first graders. So the population is all first graders. The sample is the subset of the population. So that's your 50 first graders that were taught the new method and the 50 that were taught the currently used method. So that's a total of 100 first graders in the two samples. And your experimental units, those are the individual first graders chosen for the study. Now, your control group is the first graders who are getting the currently used method. Nothing's changing there. They're using the method that's currently used. The explanatory variable, that is the teaching method. That's what we are looking to see if it causes a change. The treatments are the current method and the new method. That's what's being assigned by the investigator. And then the response variable, that's what we're going to look at to see if there's a change. So in this case, you'd be looking at the test score at the end of the 8 weeks. And is this observational or randomized experiment? Well, because the investigator is assigning a treatment, that would be a randomized experiment. All right, so researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 men between the ages of 50 to 84 are recruited as participants. The men are divided randomly into 2 groups. One group will take aspirin, the other group will take a placebo. Each man takes 1 pill each day for 3 years. At the end of the study, researchers count the number of men in each group who have had heart attacks. Identify the following. So the population, that's who we're studying. That is adult men between 50 and 84. All adult men. And the sample would be the 400 men that were chosen for the study. The experimental units are the individual men in the study. The control group would be the people that are taking the placebo. And the explanatory variable, that's the type of medication that we're trying to see if it has an effect. The treatment is either the aspirin or the placebo that's assigned by the investigator. And the response variable is whether or not the subject has a heart attack. That's what you want to see if it has an effect on whether or not they have a heart attack. And then, was that the last one? Oh, so what's not on here is this an observational study or is this a randomized experiment? And because they are assigning the aspirin and the placebo, we're going to say that this is a randomized experiment. All right, so it looks like we are finished with chapter 1. Yay! All right, let me know if you have any questions.